Human but be able to you're just exhibit so the speak sentence a logo or to like adult these ads and then she sent this to is well and so she said that the store more stick it with
I did. Those that happen exhibition. You have an invitation over there, just to
exhibition.
at the flunker.
That's why we decided like a poster or something. Not poster, this exhibition table.
That'll help. Yeah. Sure. Always.
The deadline passed. She never come.
I don't feel happy. I said they could make like
I think you're about
proper.
anyway.
Sure, yeah. See if the same. A bracket A if A T H Y. Back you to kill.
Wow. Hope all of you had a very great holiday, haven't you? So, how many of you have traveled like somewhere, like outside the state or in another country? Have you? How wonderful. I was not actually able to travel that much. I was stuck here because I had some deadlines to meet.
Working perfectly.
Since it's been a while, it's been a lot of days. I don't know if you remember the lessons that we had before the break. Uh, I don't know how much you are able to remember, how much you're able to fetch from your memory. So what I will do today, I will actually give you some brief idea of how we design uh, Boolean circuits. So what is Boolean actually? Boolean is basically, as we all know, like computer processes and stores our memory, different data. So like ones and zeros, the onwards, right? That is what Boolean is called. So now in this class, I will try to give you a brief idea of how actually we design circuits that stores and processes these ones and zeros. Okay. Uh, and also, and her later part of the lecture, I will try to give you a very brief overview of Microsoft Office, especially Microsoft Word and Microsoft PowerPoint, which are very handy when you want to represent your research or your homeworks. In your future life, you will be using these Microsoft Office a lot. So that we use it every day, but there are so many details, there are so many features in Microsoft Office, each of the like Microsoft Word and Microsoft PowerPoints, that if you know a little bit about those, it will be very easy for you to, in your future. So I will begin by the discussion of analog circuits and digital circuits. Uh, so how many of you know about the difference between these two, analog and digital? And anyone, do you have ideas, or do you have like very elaborate ideas in your mind? What is analog and what is digital? So I actually imagine something when someone says analog and digital. From my childhood, I have just heard about watch, right? Analog watch and digital watch. Everyone has heard about it, and everyone actually has used these things, right? So analog is something when you have a continuous data, right? Like continuous. You can imagine any data. Like think about an analog watch. So how the analog watch is giving you the time. So the needle is actually spinning, right? The second minute something. So you have a continuous amount of data. But a digital is something when you don't have any continuous data, when you have discrete data. Like let's say if I ask you, uh, how many laptops do you have? So you tell me I have one laptop, or someone tells me I have three laptops, two laptops. So you tell me an integer number. You don't tell me that I have 1.5 laptops, right? So it is something we call discrete data, and digital is something we can basically discrete. It is not actually continuous. Uh, we will actually dive a little deeper on the discussions. So basically, what analog is basically something which have continuous flow of values, and digital is something which is not continuous, which is basically discrete. Okay. Uh, so as you can see from the right side here, we have analog signal. So you can actually pick any point, right? You can actually pick any point you want. The data is there. But if you have a digital data, you cannot actually pick any point. You have discrete levels of points. Either you have zeros, either you have ones, right? You cannot say, okay, in the right side you have 5 or 0.5, right? You have either 0 or either 1. So this is basically a really basic difference of analog and digital. And based on this, we have two different types of circuits, which are basically analog circuits and digital circuits. So at the very beginning of our lessons, you saw circuits, right? I gave you this kind of circuits, if you remember. Uh, so you have different level of resistances, different voltage levels. Based on that, you calculated different currents, right? So you remember we often got values like 2.5 ohms, to 1.2 milliamps, something like that. So we have a continuous type of data. So this kind of circuits we typically say that okay, we have a analog circuit. And another thing is that if you look at the voltage source here, it is basically says a sinusoidal voltage. This symbol is basically sinusoidal. Do you know what sinusoidal is? Sinusoidal is basically like this, a wavy voltage. So when you have this kind of wavy voltage, it is basically analog because you can actually put pick any value and it is a continuous data. But uh, in case of digital, we will not have this kind of choice. We will have discrete values. We cannot pick any values. Okay. So we will dive a little deeper to the subsequent slides. And uh, digital circuits basically like that. Already you already have heard about gates, right? AND gates, OR gates, NOT gates. So uh, have you ever encountered any this kind of logic gates which have, let's say, 0.5 in the output or 0.2 in the output? No, you had either 0 and 1 at the input and the output, right? Zeros and ones. So this is a classic example of digital circuits. And when you actually see this term digital, now you know what it actually means. It actually means that you are actually processing the data in digital manner, like zeros and ones, right? So what is the problem with analog and what is the problem with analog or what is the advantages of analog data? So as you can see, like you analog data is very inconvenient for transforming from one place to another. Why? Because you are not actually sending, let's say, you are actually sending a continuous data, right? And let's say you are sending a sinusoidal wave from somewhere to somewhere. Now noise comes. It takes noise, right?
When the main signal is added with noise, the analog data becomes like this. So it's very inconvenient. It picks noise, and when it picks noise, it gets distorted. And when someone receives it, it's really hard for him to actually subtract the noise and recover the exact signals. This is one problem with analog. Why digital doesn't have the problem? Because in digital, let's say you are actually transforming only zeros and ones. So what happens when you only uh, transfer zeros and ones? Either transfer equals 0 or 1, 0 or 1, something like that, right? Even if it picks noise, use that is what.
They want. Okay. I
So as I was just saying, when you have like this kind of zeros and ones in your data, even if it picks noise, it's something like this, right? Someone will know, okay, this part is basically 0. Even if it looks distorted, it is basically 1. Sorry, not 0, 1, it is 0. So it is easily distinguishable. So that is one issue with analog signals have, digital doesn't. However, digital has some disadvantage as well, which we will actually discuss in the subsequent slides. But now you know why the another actually disadvantage of analog data is uh, storage. So it's very easy to store digital data. Like we can store zeros and ones very easily. So last lecture I have talked about transistor, right? Transistor is basically switch, turn on or turned off, zeros or ones. But if I tell you to store analog data, like I want to store 5.91, you see how precise the value analog has to be, because 5.9 was is so different from 5.5. You see my point? So you have to drastically come up with a very innovative storage device, which is also a scope of research. And there are analog storage devices as well, but uh, it is much easier to store digital data than analog data. So there are some, these are some of the advantages of digital data uh, that I have just discussed. There are some advantage and disadvantage of analog data in this with other disadvantages as well, which we actually discuss later. But so far, what we have learned is we have analog data, which is basically continuous. We have digital, which is like something discrete data, right? Discrete levels of data. What is basically Boolean? Boolean is basically when the discrete data is zeros and ones. Only have two values. Like the previous, like I was discussing. This one. You see that it says 01001. Like the way our computer actually stores and processes data is basically Boolean. Zeros and one. Boolean means two. You have two different zeros and ones. So when the discrete levels or digital values have only zeros and ones, we call it Boolean. So today actually we will discuss Boolean circuits. And you already are familiar with Boolean logic gates, right? Like AND, OR, NAND, NOR, XOR, all the gates that you have studied so far are basically Boolean gates. Why? Because you already know, like they processes data only zeros and ones, right? Like if you give in two zeros in a OR gate, what will happen? You will get another zero, the like this. So, but the symbols you see here is basically the symbols. They do not actually look like that. Can anyone tell me what uh, uh, consists inside these gates? How do we make these gates in real life? Do anyone have any idea? Uh, Yeah, transistor, excellent. So we typically make these digital gates or Boolean gates by transistor. So today I will try to actually give you an idea how we make these logic gates from transistor, because these are the heart, or you can call it brain, of our modern computing system and computers. Like in each of you laptops, there are billions of trillions of these logic gates. They are basically calculating everything. When you actually click a mouse, okay, you will opening a documents in your laptop. What is happening? there is some calculations going on inside your laptop, right? And how these calculations are going on? Because there are trillions of logic gates inside your laptop, and they are doing the Boolean calculations. So it is very crucial and very important to know how these logic gates are basically made, or how they are actually designed from transistor. And you already are familiar with transistor, right? So I will actually provide the brief introduction of Boolean circuits in whiteboard for your convenience, and then we will simulate the circuits um, in a free simulation tools, which is Circuit Lab. You can actually try Circuit Lab. I will show you how you can do that. So I will do the brief introduction in whiteboard. It's much more convenient than here. So these are the basic circuits of 4 different gates. For example, NAND gate, NOR gate, NOT gate, and XOR gate. Are you familiar with the schematics here? Can anyone tell me how the AND gate is designed or the NOR gate is designed here? In a previous lecture, was this discussed? Like how these are basically designed? Do you remember it? Okay, so it is really easy. So think about it. There are 2 types of transistors, right? As you all know, like NMOS, and another one is what? PMOS, right? Any confusion about these 2 symbols? So this is basically NMOS, and this is basically PMOS. Okay. So when NMOS is given a high voltage at the input, the NMOS turns on, right? But for the PMOS, why we actually give a 0 at the input, the PMOS turns on. So these 2 have conflicting nature, right? One turns on when we give a high voltage here, and another turns on when you give a 0 voltage here, and vice versa. If we give a 0 voltage here, it turns off. If we give a high voltage here, it turns off, right? So if take the difference here, now based on these 2 property, we can actually possibly design this kind of logic circuits that behave in a certain way. For example, think about a NAND gate. Okay, NAND gate. So let's think about a 2 input NAND gate. We have a 2 input X and Y, and this is the output. And we all know what the output should be for different combinations of these logic gates, right? So can you tell me what the outputs are for the NAND gate?
0, 0, 0.
Here?
0.
Are you sure?
Not get. Oh,
If CP1,
yeah.
it is 1, it is 1, it is 0x. This is how a NAND gate's truth table looks like for different levels of input. Now, let me tell you, this gate actually turns off, or this gate gives a 0 only for one case, right? When there is 2, 1, think about it. When we are giving 2, 1, the output should be 0. For all other cases, the output should be what? 1. Now let's design it. Let's think about it. I just mentioned that, okay, there is a transistor which is called MOS. When we give a 1 here, it turns on. Think about it. if we have two NMOS like this, it's like a tap with two knob, two switch. When you give one here, it turns on. And when you give one here, this turns on as well. So when you give 2, 1, the whole path from here to here is open, right? It's open to flow. Are you guys with me or lost? Think about it. If you have two NMOS in series and you give one here or high voltage here, one means high voltage, or and high voltage here, they are series, right? So if an electron tries to travel from here to here, it can do that, right? Because both of them are on. Think about it. For all other cases, like if you give 0, this will turn off. Okay, this is 1, this is 0. This is on, but this turn off, right? So for both of them to remain turned on, you have to have 2, 1, right? This is good so far. So we want to design a gate which gives 0 when both of them are 1. So what do we do? If we have an output here and this is a ground, what will happen? If both of them are 1, then output is connected to what? Ground. And what is ground? Ground is basically 0 voltage. So we will get a 0 at the output, right? You are with me so far? Do you guys have any confusion so far or any question? So what we had done here, we look at a special case. Both transistors are on and we get a 0 at the output. Okay. So we keep two NMOS in series. Okay. And this is the output node. And when both of them are 1, the output has a connection with ground. And we will have a 0 voltage. This is how actually we design any Boolean circuits actually. Now actually let's dive a little deeper. This is not the exact diagram that we have seen there. So how to actually design this? So you can take a note if you want, or inside the slide it will be available as well. But for you, for instance, if you want to take note. So any logic circuits will have two different networks. One is pull down network, and one is pull up network. You will know what this typically means, okay? And the input will go this way, and we will have an output here. The pull down network will pull down the output to the ground or 0, which will call it 0 volt. And the pull up network will connect the output to VD or high voltage. Or we can, it is basically 1. Okay, it is basically 0. So this is the basic. Basic means all logic gates are basically designed in this fashion. Okay, we have a pull-up network. The task of the pull-up network is to connect the output to what? VDD. When necessary, not all the time. I'm not saying the pull-up network will always connect the output to VDD. No, that is not true. In some cases, and in other cases, the output will be connected to ground or 0 volt or 0 by pull down network. So we have, as you can see, we had different logic combinations, right? Different logic combinations. There are 4 combinations here, right? For some combination, the pull up network will connect the output to VDD or high voltage. For other combinations, the output will be adapted to what? Ground. So I am pretty sure you have not understood 100% of it because I have not actually discussed all of it yet. But so far, if you have any question, please feel free to ask because it is really crucial to understand these steps. And by the way, it is very easy. Once you understand the game, it will like if I give you much complex circuits, you can design it by yourself. Okay, so no worries at all. So just we have seen. Okay, this is the NAND gate. How we designed? I told you if we have two NMOS in series, it connects the output to. Okay. As we were discussing, we had two different networks, pull down network and pull up network. So pull down network is basically a circuit of NMOS. Remember, pull down network is circuit of n-type MOS or NMOS, and pull up network is made of p-type MOS. Okay. And just now we have discussed that for designing a NAND gate, and NAND gate has what? If both the input has 1 or high voltage. So 1 is basically means high voltage and 0 basically means 0 voltage or low voltage. Okay. So if we give 1 at the both input, the output should go where? 0. And what network? Which of this network actually takes the output to 0? If I ask you. The pull down network, right? And pull down network is made of what? NMOS. So we will do what? We will just have two NMOS in series like this. One is, let's say, X and one is Y. It goes to 0. This is our pull down network. Okay. Do you have any confusion? So we have two NMOS. They are basically in series. And this is the output node. This is our pull down network. Pull down network. By the way, we have not drawn the pull up network yet. Always try to draw only one because the other you don't have to calculate. You don't have to think. You just follow the. I will tell you how. Whatever you have done here, do the opposite for pull up network. Let me explain it. So here we have NMOS and there is series. The pull up network will have PMOS. They will be parallel. Let me repeat. If you had NMOS in series in your pull down network, in your pull up network will be PMOS. They will be in parallel, opposite. So how will your pull up network look? Okay, your pull up network is basically very easy. I can erase this, right? You have already drawn this already. So pull up network is basically we have two PMOS in parallel. One have X, another have Y. This is VDD, and this is the output. You are with me so far? Do you guys have any confusion? So let me revise the whole thing again. We have two networks. How many? Two. Pull up network, which will connect the output to VDD. We have another network which is pull down network, which will connect the output to where? 0. Design the pull down network first and then do the opposite for the pull up network. Then connect these two. Okay, connect these two. That is your main rate. So the schematic, overall schematic or overall circuit for the NAND gate becomes like this. Look at this is the pull up network. Input now, pull down network. And this is the output. X, Y. how many of you if have confusion in this particular schematic? Because if you understand this, the next one will be just a repetition. Very easy. Please help me know. Do you guys have any confusion? Okay. Now, it is basically a very small circuit, right? It only has 4 transistors, 2 input, right? Let's check these logical combinations. Let's take these combinations. Okay, this is 1 month. Well, we have x and y both 0. What will happen? X and y both 0. This is 0. This is 0. This is 0. This is 0. X, y, right? And PMOS turns on when it is 0. So this is on. This is on. This is off. This is off. Think about it. The output, does it have any connection to the ground? Because both of them are off. But the output has a connection with what? VDD. The output has a direct connection to VDD, either in this path or this path, right? So output will be what? VDD, right? And VDD means high voltage. It is basically 0.7 volt, 1 volt, it depends. But it is high voltage. So when both of them are 0, these 2 transistors actually takes the output to where? High voltage, so VDD. Basically 1, right? So when both of them are 0, output is 1. Are you guys with me in this particular combination? So let's go to the next one. 0, 1. Why? One input is 0, but this input is 1 now. This input is 1. X is 0, this input is 1. What will happen? This PMOS is on, this is off. Because PMOS, if you give a high voltage at the input, what will happen? PMOS turns off, right? This is 0, that means this is off, but this is 1, this is on. Now what will happen? Anyone? Yeah. So you will always think about, okay, is the output connected to VDD or is the output connected to ground? Is the output connected to ground? No, because this is off. This is a blockage. The output cannot get connected to ground. Is the output connected to VDD? Yes. This is blocked, but this actually take it to the VDD. This is a parallel connection. You don't have to have all the connection open in parallel, right? If this is blocked, this is open, that output is another VDD. We get a 1 at the output. You see? You guys are with me? Same process you can check for this combination 1 0. When x is 1, when x is 1, this will turn off. This is 0, this will be on. So output will be VD again, right? This will be off, this will be on in this case. Set. But think about it. 1 1. Now the whole game will change, right? 1 1 will do what? Both of these will be on. And both of them will be off. Sorry. Both of them will be off. Now the output is connected to what? Ground only. That's so you're getting 0 volts. Okay. So for a NAND gate, we have 2 NMOS in series to the ground. Now, actually, let me ask you how the AND gate will look like, not NAND, AND. Anyone? This is the NAND gate. How the AND gate will look like? Actually, the AND is not made without the NAND. We always thought, okay, alphabetically, AND comes first and then NAND, right? Not of AND. But no, actually the NAND is the fundamental gate. NAND is the fundamental gate. Another fundamental gate is NOR. While you connect the NAND gate with a NOT gate, Are you guys familiar with the NOT gate? Let's draw the NOT gate first. What is a NOT gate? NOT gate is basically a single input gate, right? Single input gate. We also call it what? It has another name. Inverter, right? Inverter. So if I give 0, output is 1. If I give 1, output is 0. This is NOT gate. Let's explore now. So NOT gate basically looks like this. You have an NMOS here, and you have it PMOS. VDD done. So this is the NOT gate. So let me ask you, what is the pull up and pull down network gate? What is the pull down network and what is the pull up network gate? It has a pull up and pull down network, right? It is a gate. It must have a pull down network and must have a pull up network. Pull up and pull up. What is the pull up and pull down network gate? So basically, this PMOS is only the pull up network, and the NMOS is pull down network. Okay, so every gate, this is the most basic gate inverter. So when the equal is what 0, what will happen? The input goes to both of them, right? Input goes to both. So when the input is 0, what will happen? The PMOS will turn on, NMOS will turn off. So the output will go to what? VDD. And VDD means what? 1. So when the input is 0 out 1. You guys are with me so far? When the input is 1 or high voltage, then the NMOS will turn on, the PMOS will be off. The output will go to what? Ground. And we have a 0 at the output. So this is turning 1 to 0 and 0 to 1, right? That's why it's for NOT gate. It just flips the weight. If you give 1, it gives 0. If you give 0, it gives 1. So how a AND gate is made? AND. You are now familiar with NAND. You are familiar with NOT. How a AND gate is made? AND gate is basically the combination of NAND and NOT is basically AND gate. Okay. Just splits the output of the AND gate. Now let me draw the AND gate. Okay, let me ask you a call first. Are you familiar with the symbols before? Different symbols of the gates. So this is the symbol of the AND gate, right? And this is the symbol of the NAND gate. So basically, it looks like, okay, if I have a AND gate, I can make NAND gate. No, the situation is not like that. Quite the opposite. If you have the NAND gate, you can make an AND gate. How? You connect the NAND gate with a NOT gate. Then you will get what? A AND gate. Right? We can just keep it note or draw it. And let me show you the schematics to make you a little bit clear. We already know both of the schematics for both of them. What is the schematic of or what is the circuit of the NAND gate? Circuit of the NAND gate is basically two MOS and we have two PMOS, right? It is VDD, it is down X, Y, X, Y. This is the NAND gate. And if you connect the output of the NAND gate with the input of the NOT gate, let me rephrase. If you connect the output of the NAND gate with the input of the NOT gate, then we will get what? A AND gate, correct? Are you guys with me or lost? Please let me know if you are lost, because if you are lost now, I can easily rewind back the whole thing. It's really easy. But if you lost in the deep in the ocean, I cannot rescue it. Okay. So please let me know right away. Okay. Stop me right there. Uh, let me know right away so that I can figure the whole thing. It's important. It's really important part of the whole process. So as I was saying, this is the subject for the NAND gate. And then when you connect the output of the NAND gate with the input of what? In NOT gate. See? This is ground. This is VDD. Now you get the output of it and gate here. This is the schematic of what? AND gate. Are you guys with me? So which gate has more transistor? NAND or AND? AND. How many transistors does NAND gate have? How many transistors are in the NAND gate? This is the NAND gate, right? How many transistors are there? 2 PMOS and 2 NMOS. Sorry, 2 NMOS and 2 PMOS, right? 4, right? 2 in the pull-up network, 2 in the pull-down network. We can also call it in this way, okay? How many gates are in the AND gate? This whole thing is the AND gate. How many transistors are there? 5, 6. So which gate has more transistors? AND or NAND? AND, right? So which gate has more area or takes more power? AND gate, right? So now we will go to NOR gate. Are you guys familiar with NOR gate? Have you heard of it? Or have you heard of OR gates? I think most of you have heard about OR gate, right? Not NOR gate. NOT gate is basically the reverse of OR gate. When the OR gate gives 0, NOR gate will give 1. Same relationship of AND and NAND. Okay, there is an AND, right? AND means not. NAND basically is not AND. It's NAND. So the truth table of NOR gate of what? This is the truth table of NOR gate of the 2 input NOR gate. Okay. Two input NOR gate. Can anyone tell me the truth table? Like when this is the C-board of the NOR gate. Okay. Don't bother about the C-board from now. So can anyone tell me what's the output gonna be for all 4 of this for the NOR gate? By the way, I have already told you, if you know the OR gate, you can just flip it, and that is what output for the NOR gate. And anyone tell me the output for the OR gate? Just flip it. So what is 0 0 output for the OR gate? 0, right? So the OR gate is 0, but for the NOR it would be, because it's NOR, not OR. Okay. What is 0 1 for the NOR gate? 1 for the OR. So NOR will give it 0, right? Are you guys with me? Same goes over here. And whatever 1 1, 0 as well. You see? This is the truth table for NOR gate. And if anyone asks me, okay, why are you drawing the truth table of NOR gate? What is the OR gate? Basically reverse. This is the truth table of OR gate. When the NOR gate is 0, you see? Basically reverse. Okay. So now let me design the NOR gate by transistor like we did for the NAND gate. So please make sure you understand how the NAND gate is designed, because otherwise you will not understand it, okay? So let me actually ask you. The NOR gate actually gives a 1 only for one case, right? The NOR gate is giving 1 only for one case. What is the case? Well, both of them are 0. What turns on when input is 0? PMOS or NMOS? PMOS. If you give a 0, PMOS turns on, right? So let's speak about 2 PMOS in series. 2 PMOS in series. And here is the output. Here is the VDD. Think about it. Well, both of them are 0. Both of them will turn on. And the output will connect to what? VDD, right? So this will be our pull-up network for what? This NOR gate. Please let me know if you don't understand this part. Have you seen this part? So let me repeat again. For the NOR gate, when both of them are 0, the output is what? 1. So I am just connecting 2 PMOS in series. So when both of them are 0, the output is connected to what? VD. This is our pull-up network. So I already told you, only design pull-up or pull-down first. Then do the opposite for the other. We had our pull-up network, okay? Now let's design the pull-down network. Pull-down network has what? AMOS. And if 2 PMOS, here there are 2 PMOS, there is series. In a pull-down network, we have 2 AMOS, which will be in parallel. So our pull-down network will look something like this. 2 AMOS, they are a parallel. This is our pull-down network. And type this. This is X, this is Y. Like this. This is our circuit for the NOR gate. Please let me know if you don't understand this one. NAND and NOR are the main thing. Like if you have NAND and NOR, you have everything basically. And you already know the NOT gate, right? It is very basic. So you have NAND, NOR, and NOT. You can make any gate by this 3 actually. These are all universal gate there for a reason. So there are 3 universal gates. Okay. These 3 universal gates are NAND, NOR, and NOT. Why they are called universal gate? Because you can make any combinations of logic, even any other gate like XOR, majority gate, there is gate. You can make all of them by these 3 gates. If you know the circuit for these 3, you can make any logic circuit. Okay, so it is very crucial to understand these 3. I mean. Okay. So I am assuming you have understood the NOR gate so far. Let me ask you, what will be the diagram or schematic for the OR gate, not NOR. OR gate. Can anyone be any? Or yeah. That's very simple, right? I don't think there or some of them actually got lost because I will give a advanced Boolean expression later and tell you to design it yourself. If you don't understand this, you will it will be jargon to you, the next expression. So let me ask you, have you understand NAND and NOR? So this is basically the schematic for the NOR gate. We want OR gate. What is the difference between these two? Just click. Clean. You can not just connect a inverter or not gate here this way. So let me. The board is pretty small. So this is the symbol of NOR gate. This is the symbol of OR gate. So if we want to OR gate, we can just connect a NOR gate with it NOR gate. Okay. So this is OR, this is NOR, and this is NOR. So in terms of the schematics, we can just connect the output with an inverter. Okay. And this is our OR gate. Are you guys with me? So let me ask you again, which gate has more transistor? OR gate or NOR gate? Anyone here? Which gate has more transistors? OR gate. How many? 6. 6 and NOR gate is how many? So do you see a similarity between NAND and NOR? They're like two siblings with just the opposite, properties. Like here there are two NMOS. Oh, sorry, I forgot to add ground here. Will be delete. So for the NAND gate we previously drew, we have two NMOS in series and PMOS in parallel. For the NOR gate here we have two NMOS in parallel and PMOS in series. Okay. Okay. Now your task is to draw the circuit for this. Okay. What's in the job is there are three different gates here. One is let me tell you what this is. This is NAND. Sorry, this is not. I do mistakes really well. This is and this is NAND. So this is X, Y. This is A, B. This is out. So do you have any confusion of what I am asking here? You already know the circuit for these gates, right? You already know the circuits. Now draw the circuit for the whole thing.
Awesome.
Are you able to draw it? So let's think about the individual gates, okay? Like how the NOR looks like, how the AND looks like, and connect how the NAND looks like. Draw them individually first. Let's add those. That's it. Oh, you already has. Whoever I'm first can have a DR. So it's some you don't can draw it. You give us all of it. All of it. So yeah. But you can discuss between each other. You want. Think about it. This is not NAND. It is AND, okay? So if you have NAND, then you can connect it with the inverter to make it work. Anyway, so this whole thing translates to something like it. If we actually simplify things down for you, this is not. And this NAND will be something like this. You had a NAND connected with a NOT. They connected with another. You cannot actually make this and it without NAND effect as an effect. So this is basically to simplify uh, symbol or diagram something.
But
Now you have all of this, I think, from there, right? You easily draw it. How are you guys doing so far? Um, maybe in the lunch. So, like,
exactly which. Yeah, that's where the tree is. So you see the this is the main gate, right? Last main gate. It has two inputs. Think about it. One of its input comes from the output from here, and one of it another input comes from the output from here. Sure. But you can can I yeah you can give it a label like how can I call like out one and out two. So these will be basically connected
to the PMOS panels.
to the pinholes. Like these are one of the input will connected to one of the pinholes, and this same input will connected to one of the eggs. This will be connected to another PMOS, and the same will be connected to another of the eggs. Something like that. Because it's unique. We got deeply. Do you? No. I will try the board game here. Here. You are facing difficulty. Right. Think about it. We have a we have a NOR gate, right? So I will actually draw the schematic here now. So give attention to it. I think if you understand it, it will be really the next. So we have a NOR gate. What is the schematic of the NOR gate, right? Think about it. We have two LMOS. Oh, I don't have Abyss veins on the board. I didn't even. If I was coming information, in a good and that's and by she uh, also app. Well, yep. So, what's an outcome? This is your topic. This coming in. Thank you. Yeah. These are the owners or this and upwards of points. So it doesn't mean I want A to word D, which we have to. Okay. I think few of you, two or three of you have only read and group released it. So just go back to the sequel that I drew and just match with it. This is basically the NOR gate, right? We had the NOR gate here. We had the AND gate here, AND, right? So this is the NAND gate, and the NAND gate's output will be given to the input of the NOR gate. So now we have of this output going to where? Another NAND gate. So this is the symbol of the NAND gate. So Now this to output will be given to the input of this NAND. So let's see. This is and don't forget to add ZD and GND to each of them. Okay. So it's times two. Yeah. The only part. Yeah. And it is just just so think about it like you have X, Y here as well. So these are also shielded. So for example, simply the if not we have that, right? You have X, Y in both the pinos and these two X are basically come from a single wire. They are connected, but I have just labeled them not to mess up the whole. Okay. You can label it. For example, I could also give a label here, right? Out one, put one, output two. Okay. Outside, two. Then just erase it. And okay, this is output one, this is output two, this is output one, this is output. You do it zip fast, but here. Yeah. So I okay. Launch, Aliki, and catch it. What should I look? I do just walk around. It doesn't mean mass. So far, so good. So, which one of these cakes? So, these mass cakes, we are doing to rest sheets. It's a cubable bit of it. And one of the published one hour put one here, and another thing you look about this year, right? So, this week, both the one I was, I think, is usually go to here one, another place, and so the dance. This, sure, those people, you should do. Um, who's already boards of one as Elmos. One famous symbol is basically like this. In is underpinning. And this will go to the another so Android display and another of the net. Those okay. Look that I but yeah. That's matters or for notion. It is inmost. So inmost symbol has been now up like this. So it's stripped Hershey's. It doesn't matter that you are giving the left side of the required side. This is a symbol. Okay. And it's basically like is four. So since I already gave instruction, I think you can help where to remove the trauma the box. So you let it split as a split. Is what things because essentially the after of these two how I it's like here soft the and gets quick here. So those are one thing's like don't really get to oral either A in T notation. They are random. Great. These are basically random. I taken from it. So all of the inputs are now going to be one of the 10 inputs. So like shot. Yes. Cook the look. So yeah, let's like it is all. Okay. So one thing I think most of you have been contributed into the connection of the last block. Think about it. You have two input. What is this? It was a NAND gate, right? It was a NAND gate. And one of the input was coming from video and one of the ones from outside. Something like that, right? So one of the here input was coming from here and another was from here. Now, think about it. When I have drawn before, like X, Y, what I meant is the X input is basically like this. They're connected, but I have not actually drawn it. Just gave it the label X. They are basically the same thing. This is Y. So one of the connection from here will go to Y and this Y as well. And this output will go to X and this X as well, okay? So Harim is all right. So I will just go ahead for some, what are the Boolean expression of this? So how do we write complex logical expressions? Let me actually give you some examples. So you are already familiar with the basic gates now, and NAND, NOR, or and NOT, right? These are basic gates. I will not bother for the XOR now. You will know eventually after. So what are the expressions of this? Right? How do we write in a descriptive way of these Boolean logic gates? Like how do we describe? So basically, when we have a AND gate, X, Y, AND gate, I'm talking about AND, and we have is Z at the output. We call it this way, Z equal to X, Y. Okay, is basically X and Y. Okay, you can call it like take a note, X and Y. Okay, when we had a OR gate, not OR gates, we had X, Y, and Z. We call it X over Y. It is a class notation, but when you think about Boolean expression, it is OR. So dot is basically means a Boolean expression means and plus means OR. Okay. I hope you remember the prep. Dot is basically what? Not multiplication. So think about it. When we multiply 1 and 1, what will happen? 1. So the AND gate is basically performing a multiplication, right? Are you guys with me? So AND gate, when does an AND gate gives a 1 output? When both of them are 1. AND gate gives a 1 output when both of them are 1. So basically it is multiplying. Sorry. If you give 1 and 0, multiply 1 and 0, what will happen? 0, right? Multiply 0 and 1, what will happen? 0. Multiply 0 and 0, what will happen? 0. Multiply 1 with 1, what will happen? 1 into 1 is 1. So added is basically performing a multiplication task. And it is basically performing a multiplication. That's why the dot is basically describes AND. Okay. And plus, this plus sign it basically describes OR. This is not plus, this is OR.
You don't like numeric? So
Sorry,
can anyone tell me what have I written here? Boolean. Boolean expression. Yeah. So think about it. This notation describes what? And. So A and B, and A and B is or with C. So if I just draw the symbol, it is something like that. A and B, and this will be or we will change, and this is Z. Right? So if I write a Boolean expression now, you can draw the subject. Hopefully, right? By the way, so far I have only talked about one input or gate. Two input not gate, two input NAND gate. There are three input NAND gate, three input AND gate as well. Okay. So have you understood this one? Okay. Let me know if you have taken notes that I can erase it and go to the next step. So can anyone draw the circuit for A or B or C? What about A or B or C? So there are three input, right? A, B, C. But I have given you the option to only use two input or gate. How will you do it? How will you do it, anyone? So this is basically use something like that. We have a two input or gate. Let's do A and B first. Now we have an output. Take the C and the output with another. This is basically A plus B, A or B or C. Okay. Or there are in market there are three input or gate test. It depicts what we have. It looks like this. The keyboard is described. This is basically A, B, C, and the output is A or B or C. Okay. Anyone? Now, can you draw are you guys taking notes? You can if you want, like you can later have a look. Let's remember it. Can you draw A and B and C? If you have two input AND gate only, how you look like? A and B as C. Anyone? Anyone have understood this? Got it? What this? It is basically A and B, and they can do it C. Basically, very you have an AND gate like this. A, B, and the takes the output here with a C. Use another AND gate. This is already true. So output is okay. A and B and C. So B is basically A and B and
Now, uh, please let me know if you are okay after this. In terms of the expression, now I will give you a complex expression and you have to draw the gauge diagram. Okay. If you are okay, Papa. A dot. Oh, yes. So let me spell it out for you. A and B, B and C, T and A. And now this is all with BC and the whole thing is all with BC. So you only need 2 bits here. And whereas orbit. 2 types of bits. But multiple. So are you guys having any progress on this? So basically do NASH or KB, NAND of BC, NAND of CS separately. Then try to do OR between these 3 outputs. And we already know how you yeah. How many of you have been able to draw this one, the last one? You? That
Yeah, I don't know 3.
I didn't give it a check. Thank you.
The easy.
If she needs self both the unit, you made A and B mixed in the cheese. I'm going to make oil between his cheese here. It's slim, it's check. I was possibly you can use a
And I'm all you just use another one.
and that all will be Oh my. Right. Yes. Or yeah, you have to connect it, right? You could what you previously did, you do something like this, like shaken these trees and like this. You you to keep them separate so that the gate is it's yes, what type is coming from you, coming from the house from here. What this step? Because we definitely you can install. But I have not actually shown it there. That's why I recommend you to, but there should be alone. You already done that. Yeah, that's a okay. So let me actually draw it source cost. Yeah, is that it? Oh, that looks strange, but no, that is not it. Let me give you courage. You wasn't there. Think about it. A and B, okay, but do you know and choose this is math simple. Rule line and this simple. And is a little bit unfair because you have dot here. When you drop transistor, this has lower transistor, which is actually confusing. It has I had 6 transistors, right? You saw it. Yeah. So this is basically AB, then make a BC, then make a CA, right? Now, so you should bring it order. To see not the symbol of or. So you said AB, you have AC, you have CA. Now is it to make an or between AB and UC? How will you do it? It's to or again. Now you have AB plus BC or AB or to C. Make a OS with C. This is the AB plus BC, right? Yeah. Almost all 6. This is CA and AB plus BC. Plus is a class. It's called odd answer. Yeah. Thank you. Um, Let me actually draw it down for you. So oh, you will A bit. That's you will a BC, then do it a C, right? Then you have to make or. Make that first. Okay, make let it A and D. A and D. What A and D? This is A, this is B. Now get up A and B here. Right? Listening B and C. B and C. Now we have a B and C. Listening is B and K. C and gate. Now you have the A, B, A and B, B and C and C and D. All of these three, right? Now you want to A or between these two, right? How do you do it? You connect this two with a OR gate. Now you will have AB or B smooth areas. Right? So far, so good. Now you have AD or BC. Make a OR between AB and BC and C. Take it and use another OR gate. Now we will have AB or BC or C. Okay. So make these smaller sections first, like these, then and I can. And it was good, Swapna?
Yes, sir. Is the same B is the safe point? Like,
Yes, that's an excellent question. I was going to do it, but I tried to keep the input simpler. So this C and C are basically cell, okay? And this B are B same, and this A, they're same. I labeled it, but you can draw it this way. Let me actually show you. You can also draw it now. Well, like you have a, you have a B, you have a C here. Okay. Now you take the A here and take the A. Yeah. Take the C here and take the C here. Take the P here and you can write this words. You got it? So basically the C, both of the C are basically the same C, right? Just so now what I will do, I will draw a circuit like this or schematic like this. You will write the expression for it. 5 words, okay. So let's see if you can prove. Are you guys start with this? I can use it. Okay. What we output? Z equals to what? You got it? Like what's I'm asking here? So if you had a circuit like this, connection like this, okay, uh, okay, sorry, this more, yeah, go ahead. It's write Z, write Z in terms of ABC, in terms of ABC. Good.
just to confirm, I think I got it. Like the carbon when you do it is the or, and when you straight down it's the and.
It's the or, the and. This is now this is
That's also or, right?
there's oh, there's so there's and there's and.
So that's the difference. Just the carbon, the strict.
Or if it's down. Yes. Yep. That's high pixel. It's the straightforward. The heat. Show the here.
What? This one? Yeah. No. No. You see that again, I'm scared page only. I don't need to. So this is a home lead. It's not an end game. And the expression of something like the wine have a lead or it has something like X. Okay. Yes. Then have a BC or we'll have something like this. CD or something like this. Yeah. These three, these output. The output of the first or and second or space to another else. Something like this. The output of the second, like the third of the the third of the space. No. Well, TDPO. Sorry, it is not or, right? Because look at the alt get CD. It is AND, right? And AND is basically not the dot bit. Now, out the hard doors, but and CD is given the other AND gate. It's something like this. And the output of the ammo. Yeah. So for the overall is something like A or B. Like is CD. And A or B and B or C equivalent to number only. And the whole thing is given to what? And the third bracket. Yeah. This whole thing is and what is the assessment? Up X. I was just about the music. Yeah, apparently it's a news relevant from Mars. So there are some conventions of hand breakers in there and stuff. You don't need to actually remember. Just, um, wow. Is this actually something about what the oracle? It's okay. So here. Okay, I think more guess after you're not more on that or it's right. Uh, let me ask you, how many transistors are in this? What is the transistor count here? Anyone have an estimation? How many transistors are in the whole circuit? No, they are not NOR. NOR has
Nor has four.
NOR has four, NAND has four, but OR, HAND, these have six. Remember? Because you have extra NOT gate, right? Inverter, right? If you remember. So this has six transistors, this has six transistors, this has down.
Not it has two.
Yes. By the way, uh,
Yes.
these are two input OR gate, right? They have two input. So when someone asks you, what is the transistor of two input? No, you tell six because there are three input NOR gate as well, which have more transistor. But I'm not showing you three input gates, any of those today. Okay, for the simplicity. So six here at six. How many transistors are in total? 30. Yeah, 30 transistors. So you see, and it can do what? It can maybe process uh, 4 bit, not a minute, you know? So you actually need a lot of transistors to, process your logics. So instead of this AND OR gate, if we had NOR gate or NAND gate here, how the expression would look like. So this is basically really simple. So I think we already have completed this.
Can you repeat the question?
Yeah. So instead, we know that when we have AND gate,
So when we have an AND gate and we have A, B, C here, only need A and B, right? Instead of AND, if we have NAND, the expression will be basically the same, except we have Alex guys,
Could we invert it?
viewed as yeah, guys, I think you should give it some attention because it is really easy. Once you catch up, it will be really easy to read. So this is basically the symbol of NAND. Okay. So let me actually give you a purple thought. What will be this expression? This is not. This is now. Only this expression.
So we don't invert the value, right? Because even though you're saying it's inverter, so isn't supposed to be 1 over x, no? You get my point? So NAND,
Yeah.
we don't invert the value.
It's got some flip. If it is a 0, if you put an inverter in a 0, what happens? It gives 1. If you give 1, it gives 0. So that's split.
This R is the sign of that signal.
Yes. Yes. So these are basically not. We know the symbol of OR, right?
Yeah.
The NOR is
What about the not?
what about the NOT? That's an excellent question. So if we have the NOT gate, that's a really good thing I forgot to mention. So this is not. Flip. Okay. So, whenever we have a bar like this, okay, it means what? Not or reverse. Okay. So we know and so this is not. We know or this is not.
That's
Okay. There is another interesting thing, which is called buffer. I will discuss maybe the necessity of it bigger later. Buffer is basically if you give x, you just get x.
it again.
If whatever you give input, you get out. Set. It's called buffer. So what's the use? Sometimes we maybe use it anti-party. Let's see that. Okay. And I will discuss it in a more ethics for that discussion. So buffer, what the expression of buffer? This.
Or buffer gate. Also a gate.
Yeah, buffer wait. Some complete buffer. Okay. So you don't have to worry about buffer like
Isn't the drawing looks the same one?
Sorry?
Drawing is the same triangle, buffer gate.
Yes, a circle. Excellent. This is
Yeah.
buffer or buffer. So whatever you give input, you will be accept. Figure it out.
You share the slides in the classroom.
Dislikes or no? Actually, most of the thing that I am drawing right now on the board is not yet in the slides. So I think that I would encourage you to take some notes. Even if you don't, I will actually give you some
Helps taking some.
resources.
I'm just wondering.
So the resources that typically have so much information for you to digest at once because you have not gone through a very rigorous background so far, which is completely fine because you don't have to. So when I give you a very big documents, maybe you find it overwhelming for you. So I'll try to give you a very simple resource so that I'm not.
I was wondering if all the slides can be in the material section because I was looking at actually the classroom. Only slide 6 is there.
Oh,
Or was there probably the stream posted?
it will talk.
Can be all.
Object. I mean, a couple to boy. I think he has all the slides.
They put him in one like a metro.
I think you have read 8 classes before today, right? So this is the 9th one. If you have 6 slides ready, I think you will have 3 slides up on there, including today.
I mean, they might be posted as a stream in the class period, yeah, but it's asked to complete the trail session.
I'll let you know yet. Okay, now do one thing for me. I'm just giving a final circuit for you to find the Boolean is.
This equation, is it called Boolean?
These equations are called Boolean because you are giving ones and zeros and out with ones and zeros.
How do you spell this? Boolean?
Boolean, yeah. Good. These are Boolean. Find the expression for z. So this is not, this is glad, this is or. Yeah. Yeah, after that, I will take a break. I think the pizza is ready, right? Yeah, okay. We'll have some pizza and begin after. But I would encourage you to finish it first. I will give you the side effects. Probably it's enough. Reverse down. Wait. Can you? No. Have to see for him. Oh, there's still problem else. So, okay. I can take control. We have it. No. The one boy actually. That is why.
Don't ever put the This is fine.
I'm a call. Asia. That's what. Arrivederci. Go by the right direction. Yeah, let's go ahead and the next follow the direction. Um, yeah, yeah.
So then
Letter C.
no. So you are getting this A nor B here. You are getting B and C here. Now and and okay and this is all. No.
Oh,
So not for now. I'm just giving you for a code later. If A equal to 0, B is 0, C1 and D1. Okay. What will be the value of C? Okay. Check. So I think the lunch is ready, so we can take the few minutes break, right? Few minutes break after that, do we come back and maybe. So today actually since you have a project to submit, I think you have to write your project description or the project report, right? So for the convenience of that, I will actually try to give a very brief summary of Microsoft Word and Microsoft PowerPoint. It will not be a very comprehensive details of that because it has too many features to cover in a single lecture, and you don't actually need that right now. You once you begin to use it, you actually learn these things gradually. So let me actually ask you, how many of you have used Microsoft Word ever in your life for any project submission? I think at some point in your life you have done that, right? You have not used it yet. That's good as well because you will yeah, I think you will find it really amazing because uh, whenever you want to submit any report or anything, this is the best place.
we have to
How?
purchase the software. So
Oh, by the way, yeah, uh, you should have student access through your school. If you don't, uh, I don't know, like how I'll talk with the president, Professor Fatih, about it. How you can get some access to Microsoft Word, but they can use a blind online through virtual. Okay. Okay. So okay, what do you yeah, you can use online version of it. So pretty similar. Uh layout, I mean the design looks a little bit different probably, but once you have the brief idea about it, you can easily use it. Okay. So what you need to do is once you install Microsoft Word in computer, uh go ahead and actually uh, okay, you should actually, when you double click on it, a blank page opens like this. Okay. So now all of your writings, all of your pictures for your report, you have to insert here. So whatever you want to write, you can begin writing right away. Or you can actually set up the margin of your page before. You can do that by going layout. So as you can see, please follow the screen. As you can see, there are like countless options inside. Okay, countless options. So you see like home, you see a lot of options. You will learn these things gradually. Then you have insert options. You can insert picture, insert table, insert other details that are not plain writings. Okay. Then there is like draw, design, layout, all of stuff. And reference is for scientific references. So in scientific writing, you need to give the reference to
show the authenticity of the information you are providing. Okay, then this reference section comes. There are like reviewed. If you change your documents, if you want to track your change, okay, I have changed this, I have corrected my spelling mistakes. These things are reported in this review panel. So there are a lot of panels and a lot of options. So let's begin by the layout option. So you see, in your Word document, you have a page and you want to actually keep a definitely margin in top, bottom, right and left. Okay. So you can set up the margin here. You can go ahead and change the margin. You already will have a lot of customized, not customized, already have I default margin options. For example, you see the margins are specified. The top margin is 0.6. Can you see my screen clearly? Read it. I don't know if you can read or not. Let's see if I can. Okay. So these are different options. Okay. You can create your own margin options. For example, none of these actually satisfied your expectations. So you can custom it. Go to custom margin, you can actually change how much top margin, how much bottom margin, how much left and right margin you want to keep for your report or for your CV. So in later life, you have to build your resume, it's CV. There as well, you will be needing to use it. So you can keep different margins here. Once you are satisfied with the margin, you write-ups will automatically set. So now you can see it is a blank space. It is not a write-up. So I have already write something for one of my report. So let's just copy paste it to show you how I can play with my text here. So these are the text I currently have. So if you change your margin accordingly, the write-up will automatically change. You see, if I change my margin, my write-ups are changing accordingly and getting reshaped. So you can do it. I always try to keep it this normal option. It is, it looks good, it looks better. But if, let's say you want to reduce it a little bit, always feel free to go to custom margin and change it accordingly. Okay. Now, there are different sizes of paper. So you have always used different paper, A size paper, A4 size paper, right? Different papers. In Microsoft Word as well, you have different papers here, like letter small. If you just click on it, you see my page size actually changes. The page becomes different. This is the letter. This is small. So there are a lot of them. A3, A4. You see A4? I think we use mostly use A4, right? In our 3D. There are A3 as well. This is the A3 paper. So you can easily change it. Whatever you like. So just let me keep it in the later option. So there are a lot of other options as well. I will go through the most important of those. For example, let's go to the home screen. So you can write any text here and you can actually change the text color, text fonts, everything in this panel. Go to home and there is a panel here. This is the panel where you can customize your write-ups very easily. For example, there are a lot of fonts, as you can see, okay? A lot of fonts. So you can actually choose a particular, like, click and hold the click and select this way. And then actually you can make it bold or not, make it italic like this, a tilde options or both. You can enable both like italic and something that you can underline the page if you want or not. And you can change the font as well. For example, there are like countless fonts, fancy fonts. You see, these are like pretty cool. Like, yeah, there are like a lot of fancy fonts inside. So for formal writing, mostly Times New Roman, this font is typically used. Times New Roman is the most used font here. You can also choose to pick Arial. There is another font, Arial. Yeah, Arial. This is also another font that people use for formal write-ups, like reports, resumes and stuff. Here, this is the size of your text. So if you just click on a size, you see this doesn't change because you have not selected any text. So if you want to use the size of a text, at first select it, then change the size. Then you will see, okay, my text size is changing. Okay, so this is the way you can change it. So you can for your report keep it below 14. Okay, don't go above 40. Below 40, like 12 is okay. 10 to 12 is okay, I guess. Now, this is basically a way to increase the font size without touching this, like to see which one fits. Like you see, I'm increasing it, decreasing it, like indifferent. So this is the panel where you actually shape the overall text. For example, this is called justify. If you hover your mouse on any of the options, you see what it does. The option is actually described. Justify means is justified. That it means it is shifted to the left side. This means this is actually aligned to the middle, and this means this is aligned to the right side. Okay. So you see there are a lot of text formatting options. This is what we will use. You will use for report. This is for justify. If you justify, then you see the text are very well aligned at the both sides, right and left. Use that. This is a button option. So sometimes you will need to actually describe some list of figures, list of tasks, list of objectives, or let's say you want to describe a list of components that you have used in your project, right? You had a lot of components like resistor, inductor, something like that. So what you will do, you will go somewhere like give enter and click on it. You see, a list is created. So now I will list my component like resistor, resistance, then enter, inductance. You see, I can create a list. Then let's say what? LED. Okay. Then enter again. You see, the list is automated. If you want to end the list, then just press backspace. You see, I have gone out of the list. Now I can write my normal text again. Okay. So the list is a very useful thing here. By the way, you can change your bullets here. You can change it to number as well. Like if you want to change it to number, then okay, once you can go this to this option. See, this is 1.123. Now your list has numbers. If you don't want to use number, let's say any other option like ABC, you will have this. You see, a lot of options that you can play. You can also change it to non-numbered values like let's say here in the bullet options, you will see there are a lot of cool hooks like this. So once you begin to use it, you can play with it and you'll know which option you prefer. Then actually another simple option that you can do is you can change the spacing between your lines. You see, this is the if you hover on it, it says line and paragraph is spacing. Line and paragraph is spacing. You see, you can change the spacing between the two lines or two paragraphs. So how to do it? Just drop down, click on the drop down menu, and you see there are several options. You see, I am increasing the line space between my lines. So typically 1.15 looks really good to me. If you want to congest your writing, you can choose 1. You see, the writing is really congested. If you want to space it up, like goes beyond, it's your choice. Now, if you want to change the font color, let's say you want to emphasize, okay, resistance is red color. Like you can go ahead. Here you see font color. You can actually change the color to red. Inductance, you can change the color to blue. Like Once you begin to use it, you will have your own way to, do the idea. There are other options as well, like, one second. So if you want to insert a table, okay, so you go to insert option. So now, so far I have discussed the home panel and the layout panel. There are other panels as well, as you see, insert panel, draw panel, reference panel. So let's go to the insert panel. As you can see, you can insert a lot of things in your writing. You can insert a table, and how to write a table. Okay, so specify the number of columns and rows of your table here. So let's say I have a table which has 4 row and 5 column. Okay, how will I do that? Just click on the drop down menu and you see 4 and 5. So I definitely hope that you will have your MS Word installed in your laptop. Unfortunately, you don't have that, so you don't have to memorize all that stuff. So once you have it in front of you, you maybe you will pass some time with it, and you will know. But always come back to me if you have any question about it. So this is the way actually you can actually insert a table like this. And once you insert the table, you see a table is inserted. Now you can write it inside your table like this. Okay. So let's make a table like this, like different component and value, price, company, something like that. Okay. And other things. My cost component is resistance, then reactance. I'm just making a random table. Okay. Then I have some, let's say, LEDs. Then I have a battery, something like that. And I have my resistance is, let's say, 10 ohms. How I can write ohms? A Greek letter, right? So if you insert a Greek letter, you already also have not really insert. You can go to one step. You can go to symbol. You see, there is a resistance ohm option. 10 ohms. Okay. So go to insert, and there is a symbol. There are symbols that you can use. My inductance has, let's say, 10 microhenry. My LEDs, I don't know, it's 2.2 volt LED. So I'm just giving you random examples. Okay, you don't have to actually keep that. So let's say you want use price like $8, $1.5, something like that. Companies and stuff. That once you have the table, you can actually color and design your table like this. So let's say if you want to design this part, you get select, like you select simply go to home and use this option. Okay, this is the shading option. So you see different shading. I'm giving blue here, and I'm also bolding the font. Okay. So this is just an example of how we can use the table. Let's color this as well. This is the okay. Yeah, just giving you an example. Okay. So this is how actually you can insert a table in your writing. Okay, and you can also do this. Okay, I have this text at the left side. What about I actually keep the text in the center like this? This is justify. This is center. Okay, you see the text has shifted to the center. So keep this as center. So there are a lot, like countless options inside the Microsoft Word for you to design your own writings. And then go back to the insert panel. What options do we have? Like you can also insert picture. So you have a figure of your project. Okay, you have the figure of your breadboard. You have a figure of everything. You can capture it in your mobile and transfer it to your computer. Then insert the picture from here. Okay, let's insert a picture. So this is the picture of a laptop. Okay, I'll insert the picture in my table, you see. If you want to insert the picture somewhere else, no problem. Let's go to that place first. Enter. If you give black enter, that there will be space will be created. Then you can place your picture into insert your picture like this. And once you insert your picture, let's make it at the center. You see? So my picture is you can also resize your picture like this. You see? So when you actually write your project report in Microsoft Word, you can actually play with it and also come back to us if you find anything that's inconvenient for you. Like we can discuss about it. There are other options here as well, like text box. Text box is basically a text box. Okay, you can write text, you can insert picture in front of it. However, you don't have to use it right now, but just giving you a brief mention of ability that I have. Now, let's show you another very important thing for paper writing. So when you have a write-up ready, okay, when you have a write-up, have you seen any newspapers or have you seen any magazines that have multiple columns of writings? So this is very common in formal writing, especially in scientific writing. In your future, you will very often encounter that you have to write in double colors. Okay, sometimes triple colors. I have seen papers which have triple columns. So for that, you have to go to the layout and you see columns. You see there are multiple options. So if I just insert two columns, you see my write-up is divided into two columns. You can also choose to have more than two columns, right? Like this, three columns. But three columns is actually taking a lot of margins, right? In both sides. Like you have a lot of blank space. So three columns actually let you lose a lot of space. So two columns is actually the most, I can say the most optimum option, okay, for formal write-ups. By the way, if you think that, okay, your two columns are also taking too much space, like this space in between, you can also change your margins, right? I have already shown that you can change your margins accordingly. And also, you don't have to make everything two column. For example, let's go back to single column. Let's say you have a title, you have a project, what about the project? Parking light LED project. Okay, just giving you a random idea. This is my title. Okay, so I am making it bold. I underline it with a line. I am making the font bigger. Now it looks like a title, right? Now take it to the center. You see? Now it looks like a title of project. What about I want to change the write-ups to double column, but keep this as it is. Then select have particular text like this and make it a double column, like designed, layout, column, full column. You see, a lot of scientific papers, even if you just go through scientific papers online, most of them, not all of them, a lot of other papers of them have this kind of layout. You have title, which is in the middle and at the top of your write-up, and then you have a double column write-up, okay, which have list, which have figures, which have everything else. And now you can save your, now I will show how to save this particular documents in a particular day. So for that, go to File, Save As. Okay, if you just click on Save, if it already has a name, if the document has already name, it's a my project. If you just click on Save, it will say to my project. Or if you want to give it a different name, then click on Save As. Okay, save as, and select a directory. So I have, let's say, a lot of other repositories where I can save. Let's save it in desktop. Okay, desktop, and give it a name. Project demo. Okay. So you can just click on save here, and the document is saved as a name project demo. Okay. Now MS Word has by default format of docx. Okay. So you know PDF, right? PDF is the most common version of document that probably we send and receive, right? So how to save this document as a PDF? Can anyone tell me if you have used it? Yeah. So just use the same way I did right, and on the back, save a copy. Here, you see, save as Skype. You can change the type to PDF. You see, there are multiple type of documents that you can save it to. So we choose PDF, right? We put it to PDF and keep it to, let's say, desktop. Okay. Now, this document will be chosen as a PDF. Let's open the PDF. I have a PDF reader installed in my computer, so I will not have a problem. This is the PDF. PDF looks like a book, right? Document. So we have a MS Word document, docx file, and we have saved it to make it a PDF. So when you actually make your project report, you always do the write-ups and everything in the MS Word or any other office. Okay. Where it is generated as a docx, you edit it in docx. Then you save it in PDF and please submit the project report as PDF only. Okay. Don't submit it to any other Python format. Don't submit it in a docx format. Am I clear about it, or do you have any confusion? So always submit your project report in PDF format. Otherwise, when we open it in our computer, we see that all of your figures, your tables, all are messed up. But once you create a PDF, everything is fixed. It doesn't mess up. That's it.
Follow any particular format like MLF format or something?
Did Uday share any particular template with you? Okay, I will talk with him if he. So project will be assessed by all of us, I guess. So we will provide a format for this. So format may include already give you a docx file. So you open the docx file and edit it. All the formatting will be done inside the docx. You just edit that template, okay? So I will not fetch further with the Microsoft Word right now. This is, I think, should be enough instruction for you to submit the project. That's what my intention was. Let's go to Microsoft PowerPoint.
Submitting in the classroom?
Yeah.
Okay, classroom.
Yeah.
Assignment. Report.
Yeah, I recommend you submit it in the classroom. Google Classroom. So PowerPoint is probably the most commonly used tool for presentation or for presenting your research, presenting your project results and everything. When you give presentation to any web, the first tool you use is PowerPoint. Okay. And I cannot actually emphasize enough how important this is going to be for your anywhere you go. PowerPoint is very, very important. So right now there are more advanced level of like AI based presentation tools have been there in the market I have seen, but it's still a knowledge of PowerPoint will actually help you to use those advanced tool as well. If you don't have any knowledge about PowerPoint, you will actually not able to use the advanced one as well. Okay, so you must know basic knowledge of PowerPoint. So PowerPoint in a PowerPoint, actually you can just, for example, if you want to copy any picture from anywhere, let's say I go to folder, I want to insert a picture. Okay. Let's say I want to insert the picture. I just copy it. I can just copy and Control C, Control V. You can do that. Copy paste here. You can stretch it. You can do a lot of things with it. Okay. Now, I always recommend to keep a border in your PowerPoint page. So there are these panels are very similar to Microsoft Word panels, but they are a little bit different because in Microsoft Word you typically deal with text, right? In Microsoft Word, what you typically deal with text, but in PowerPoint you don't actually deal with text that much. Maybe a little bit, but mostly with pictures. So in PowerPoint you will see a lot of visual, funny stuff. Funny, not funny, fun stuff. So for example, like you see a lot of visual stuff. You creating a lot of shapes, 3D shapes, 2D shapes, single lines, draw like curved lines, everything you can do inside the PowerPoint, okay? So, for example, I want to draw a rectangle, okay? So what I will do, I will go to insert, I'll go to shapes, I'll go to rectangle. You see, there are countless other shapes as well, like very funny shapes as well, like block. You can feel it red. Okay. So a lot of already built in shapes that otherwise you would have taken a lot of time to draw up yourself, but it's inside the bar. So let's actually build a rectangle there. We can go to those shapes in rectangle and give a type of border. You will write inside of it. Right click on it and you will know that you can actually change the color. So I actually prefer to keep it black. And when I double click on it, it shows me I am right inside it. You see? So let's actually give it a tag. Our project outline basically. By the way, whatever I am actually showing you right now, you will not remember it at all. I know. But it's just the purpose of, emphasizing that how much important that is for your next levels. And once you begin doing this, you will have questions yourself. Then you can come to me and other members, we can help. Now, when I have written this, if I think that my the text is too small, I can actually make it a little bigger. You see, a lot bigger or not. I can take it to the left side, center, or right side. I prefer to keep it this way. Okay. Now, let's. Okay. Now, what I will do, I will just delete this picture and I will create a list here. So insert. Don't have to actually insert a text box, and inside the text box I can write anything. Like I can write that my project has begun with what? Introduction. Then in our project we have done software evaluation. Then we have done hardware evaluation. Then we have faced challenges. Then we will talk about results. Then we will talk about conclusions. However, I should have kept it as a list, not like this random write-up. So I can go ahead and click on it. You see, these have become list. We can easily make it a list. Then I can actually change the font size, maybe change the font color to blue if you want. This way, how many options do we have? Then I can change the spacing between these options like this, you see. So our projects are like. So when you begin using it, you will know that it's very community. So this way, actually, you can make simple presentation text. Okay. And I have already shown how you can insert picture.
For example, if you want to take this computer picture, Control C, copy it and paste it here. Okay, like this. I will not sketch it too much because you don't have PowerPoint on your laptop, right? How many of you have, none of them have access, right?
We all use Google Doc because you have to.
Google Docs, and they use it, can use the online version of PowerPoint as well.
PDF for this.
What? Good slides. Google Slides. Oh, sorry, Google Slides. They can use Google Slides. By the way, you will have all the options that you see here in Google Slides.
Yeah, they know Google. Like we all use Google Doc.
Oh, that's great then. I think then it's not very unfamiliar to you. Whatever I'm doing right now, it's not unfamiliar to you. That's good actually. I thought that I'm just beating around the bush.
I think if you share the template in the Word file, that would be hard for me to edit because I don't have access to Microsoft Word.
If I
Like if a template needs to be a Google Doc or something.
don't know if that will be too hard because the embedded will
just
just says that very simple format. You can just copy paste it.
Yeah, actually, if you open the Google Doc and just import the whole file to Google Documents, it will do all the modifications by itself. So just import the whole file.
Another cool thing I don't know if you have done is animation. Have you done animation in Google Slide? Now that I have learned that you have used Google Slide, oh, then I think, yeah. So just if anyone doesn't remember, we go to animation. Let's say I want this introduction to come. Okay. After a gig. Then I want this software evaluation to come correctly in a different way. These are two stuff. I think you already know it, right? So once you click on animation, I think, once you click there, this will begin and appear. So this way, actually, you can make good presentations about it. I think in project agenda, there is a presentation, right? There is a presentation. So once you complete your project, please include these particular points in your project presentation. This doesn't have to be exactly how I have written, but you should include your code snippet, whatever code you have done, a screenshot of your code. You know how to take a screenshot, right? Yeah. So just take a screenshot of your code, take the picture of the results of your simulation. Once you done, you do the simulation, it gives you no error, right? No error with your simulation. Also keep a screenshot of that. So paste these screenshots in your PowerPoint and make cool animations. That's how actually you can present. Also, talk about challenges that you have faced. You do your projects. For example, you have learned very new stuff that you are not familiar with at all. Write this in your PowerPoint. So your presentation have to be really catchy, not too much technical videos, but you are trying to attract people who don't know about anything. So you try to make it interesting. Try to make your presentation more interesting than more technical. Okay. Okay, now that we have some brief introduction of the MS Office and MS PowerPoint, I will go ahead to familiarize you about a online simulation platform, which is known as the Circuit Lab. I think you already have used it before in your previous class, right? So Circuit Lab is free, but I have learned very recently that it's free up to a particular time. You cannot actually do circuit simulation indefinitely. You just have a time limitations. So have you done any simulation in Circuit Lab yet? Transistor simulation?
Draw something. We draw a circuit.
Draw circuit with transistor?
There was resistance and
Resistance stuff. So I will show you how you can actually draw transistor relative stuffs. So here
once you open a new circuit. So at the left panel, oh sorry, I. So this is the circuit looks like, right? Inside, these are the components. And if you hover on the component, you will know what component it is. So if you don't understand what this is voltage controlled current source. What this is photodiode, something like that. So I want MOSFET, right? Right now, for my logic gates, what type of MOSFET do I need? NMOS and PMOS. So these are, you can find it here. You see MOSFET in channel. So at the very beginning of our classes, like few months ago, I have talked about NMOS and PMOS. Why it is called NMOS? Do you remember? So this was called NMOS because has a N-type channel. The electron flows through the N-type channel, comes source to the brain, right? From source to the brain, right? So that is what it is called NMOS. So MOSFET N channel is basically NMOS, and MOSFET P channel is basically PMOS. The signal are a little bit different, but don't get overwhelmed by people use a lot of different symbols. Okay, just click on it and place it somewhere. This is your NMOS. Now place your PMOS here. Okay, this is your PMOS. Now draw wire. I think you have already drawn wire somewhere here before the wire. Draw the wire like this. Who can guess what I'm drawing right now? A PMOS and an NMOS. This is basically a NOT gate, right? NOT gate or an invert. Now, I would provide a ground. For ground, go to the top left corner. This is the GND. You see GND? This is basically ground. Give a ground. And what else do we need? Can you not tell me? A VDA, right? A VDD or high voltage. So for these two MOSFETs actually operate at plus 5 volt. 5 volt. So we need a 5 volt DC voltage. You see the DC sources here? This is the voltage source. Click on it. Place it here. Okay. Now draw the wire from here to and draw this. Okay. Any confusion? So are you guys do you guys have any confusion on why I have drawn this way? So your VDD should be connected to a high voltage and that voltage source negative terminal should connect it to ground. Okay. Always make sure of that. Now, since I have already told you, this is basically a transistors are turned on at like 5 volt. They work at 5 volt. So I go ahead and double click on the voltage source and make it a 5 volt. Okay, click enter. Okay. Now, this is the input and this is the output, right? Is it the output, right? So I have two wire just taken out from the input and output. So at the input, if I give 5 volt, what should I expect at the output? Is the inverter not get? What must not get do? If I give 1, it gives 0. If I give 0, it gives 1. So for an inverter, if I give it 0 voltage, what should I get? 5 volt, right? That is the 1. That is voltage, right? 5 volt. If I get 5 volt at the input, what should I get? 0, right? That's what I'm check. So I will connect a voltage function generator here. So I want to check For both cases, if I give 5 volt, it hits 0. If I give 0 volt, it gives me 5 volt. I want to check both of these. I don't want to just check for 0 or just check for 5. So I will give a voltage generator. What I will do, I will give a pulse. Okay, I will give a pulse like this. 505050. Then I will get 050505. You are with me? So if I give 5050, then I will get 0505 because that's an invert. So I will make a pulse here. Now click on it. Create a square wave. Make it amplitude. These steps are given in the slide. You don't have to memorize it. If you want to go ahead and reproduce the whole thing, you can just cover the steps in the slide. So hit the amplitude 2.5 volt, and there is a DC offset 2.5 volt. So here, this is a square wave. A square wave has both plus and minus. I don't want it to be minus. I don't want to zero. That's why I'm giving an offset. You don't have to bother about it right now. So let's give a ground here. Yeah, my circuit is ready. Now I just want to run the simulation. You guys are with me so far? If I run the simulation, what should I expect? So I have an inverter. Think about it. I have a NOT gate or inverter, whatever you call it. I am giving something like this: 0 1 0 1 0 1. What should I expect it out to? My output should be 1 0 1 0 1 0. Right. You guys are with me so far? That's what I'm gonna check. So I have created a square wave with 1 hertz, 1 kilohertz. 1 kilohertz means 1000 pulse per second. So what was the period? 1000th of a second, right? If my frequency is 1 kilohertz, my period is 1 millisecond. 1 by 1000 second, 1 millisecond. So I will run a simulation which has only 2 milliseconds. 2 milliseconds means how many? 1 millisecond, 2 milliseconds, right? This is what I should get at the input. So that's what I'm gonna get. So let's run it. First, running the simulation, just click on simulate. Then it will tell you, okay, what kind of simulation do I want to do? I want to do a time domain simulation, right? Time, I want to see the time with respect to time. 1 millisecond, 2 milliseconds, something like that. So go time domain. Now you start time it at 0. My stop time will be at 2 milliseconds. You see, I have already done the simulation here. And my time step is 1 microsecond. Okay, 1 to the power minus 6. So you can also do this 0.0022 2 millisecond and 1 microsecond 0.000001. Okay. Sorry?
What's the start time it gets?
Start time is 0.
0.
0 means just at the beginning. And stop time is 2 milliseconds because I want 2 period at least. Then I give like run time domain simulation. Okay. You see, running transient solver, you must select at least one output to plot. I have not selected any output to plot, right? What to plot? I want to plot the input and plot the output. Click on the input. This is my input. And click on the output. Now, run. I'm doing simulation. We see, this is my simulation result. So, the yellow one is my input and the blue one is my output. Does this look perfect? So let's just separate out the input and output. Let's hide the output for a second. This is my input. Okay. So this is my output. Am I not getting the perfect input output? Exactly as I expected, right? because the transistor operates at 5 volt. I have been in 0 to 5, 5 to 0, 0 to 5, 5 to 0. This is my output. What it goes on 5 to 0, 0 to 5. So if you follow my input again, my input goes from 0 to 5, then 0 again, then high, right? So my the purpose of this demonstration was to show how we do the simulation, why we do it. Let's say you have a circuit ready, then just before the fabrication, before going to the RF fabrication, you want to check your circuit is design is okay. If design does not have any flaw, you do a circuit simulation and you see, okay, my circuit is behaving exactly as I expected. Okay, now actually you can go ahead and put your design in the fabrication process. Okay, so that the whole fabrication, you see, it is telling you to register, but will I register? No. I will just go to the incognito mode again if I want. But today, actually, I will wrap it up here because for the interest of time, I will not go to the more, advanced logic circuits. Probably in the next class, I will show how you can simulate NAND, NOR, this kind of logic gates. Okay. I had just shown the NOT gate tutorial. If you see the simulation of NOT gate. I hope I will wrap up for today. Please let me know if you have any questions. Thank you.